Okay, so if you remember, back in chapter 2, we started talking about transformations. In chapter 2, we were dealing with basic, absolute value functions and also some quadratic functions, right? Yeah. So back over there, we said that this was the form of the what do you call it? The quadratic equation. This was the form of the quadratic equation that we were using, right? So, okay. Now, this equation, and then from this, remember we were saying that h and k are the coordinates of the vertex, right? So because just by looking at this, you can basically extract the vertex. This form of the quadratic equation is called vertex form, right? Remember, throughout this chapter, we were using this ax squared plus bx plus c. That's also a form of the quadratic equation. That's the quadratic equation in standard form, right? And this is the quadratic equation in vertex form. So, and remember, in this form, what does h do to a graph? Right, so it's responsible for the horizontal translation. And k is responsible for the vertical translation. Remember, vertical is spelled C-A-L. Everybody spells it C-L-E, like cuticle. But they're different. This is vertical. Okay, and now A, what does A do to the graph? It's the stretch or the compression, right? And the sign of A, if A is negative, is responsible for what?
Whether it goes up or down.
Right, a reflection around the x-axis. Good. So if A is less than 0, then there is a reflection around the x-axis. And then if absolute value of A is less than 1, it's a vertical compression. If absolute value of A is greater than 1, it's a vertical stretch. Okay? Both of those together, like the umbrella word, is a vertical dilation, right? But then, less than 1 compression, greater than 1 stretch. Okay, so let's go ahead and just remind ourselves how we graphed this. The vertex here is 3, 4. So I go over to 3, up 4, that's the vertex. And then remember, the A value here is 1. So if I move from the vertex horizontally 1 unit, I go up 1 squared. And then if I move from the vertex horizontally 2 units, I go up how much? 4. Right? And then I mirror those on the other side. And there's my cute little parabola, right? Remember, do the vertex, it has to be a curve. Okay, next. The vertex here is -4, -6. And this one, right, we can already tell there is it's going to go downward, right? There's a reflection. So if I move over 1, I go down how much? 2. And 2 this way, and there isn't enough space for the other point, but it's okay because 3 is enough. Let's graph, and that's how that looks, okay? So wouldn't it be great if all quadratic functions were in this form for us to be able to graph? Well, guess what?
You can put them in that form?
You can put them in that form using completing the square. Yes. So, let's do this one. Now, okay, so here's what we're going to do. To do this, we basically have to work with the x terms together and everything else is kind of separate. Now, do you remember how before we were moving the constant to one side and working on left and right.
Yeah.
This time, we're going to keep everything on the same side. So here's what we're going to do. We're going to do y equals, okay, x squared minus 10x plus a number, right? And then here we have plus 4. Now, I just added a number. How do I undo it? Here it's going to be minus that same number. Okay? So before, what we were doing is plus a number here and then plus a number on the other side. Well, imagine taking that and bringing it here, then it would be minus a number here. Okay? But also, remember this equation has to be unchanged. That's why if I add 2 here, I had to add 2 to the other side. Another way to keep it unchanged is I add 2 and then I subtract 2. It suits my purposes, but it's like I didn't add anything at all. All right? Okay, so in math, the older you get and the higher and higher you go in your math courses, you realize there are so many tips and tricks that you could do. You can literally do anything you want to an equation as long as it's mathematically sound, right? Like you can do anything to suit your purposes as long as it's mathematically sound. Like there are so many tips and tricks. Anyways, what number goes there? 25. So this becomes y equals x minus 5 squared minus 21, and there you have it, the equation in vertex form. Oh my God, like seriously, how amazing is that, right? It's fantastic. I mean, it really deserves applause. Yes, absolutely. Okay, now, oops, I'm missing a squared here. Guys, I'm missing a square here. Yeah. Okay, so take a look here. This is a complication because, of course, things can't stay rosy all. Oops, sorry. Just things can't stay, just rosy and cheery all the time. Okay, so here's what we're gonna do.
Wait, is this supposed to be squared?
Yeah, I just added a square.
It's really cute.
Yep.
I thought it would be x plus 5 in this square.
No, because there is a negative here.
Yeah, no, but it's a times x minus h. So there's 2 negatives, right? So it would be positive.
Oh no, that stays the way it is. No, okay, so h would be positive 5.
H would be negative 5.
H would be positive 5.
Negative 10 divided by 6 is negative 5.
But then you square it.
When you square it.
To get the.
Okay, so let's work backwards. So this times this is negative 10 times x. That does give you negative 10x. Remember, we don't change the sign of this. Whatever that is, it just stays consistent. Okay? All right, let's do this one. So this one has a negative 2 out front, which we can't have. So what we have to do is take out the negative 2. But here's what we're going to do. Take out the negative 2. So this becomes x squared minus 3 over 2x. Okay? Because we took out a negative 2. Okay? Now, listen to me. Now it's going to be plus a number minus 12. We don't divide that. Minus a number. Okay?
Wait, why don't we divide the 12?
Huh?
Why don't we divide the 12?
Because you'll see right now we're going to compensate for that 2 in another way. Okay?
Minus 12 minus 6.
So, what goes in that space over there? Negative 9 over 16. I'm sorry, positive 9 over 16. Right? Because you square it.
Oh, yeah.
Yeah? But now, here, you add in negative 2 times 9 over 16. Yes.
But because you multiply.
Because we took out the negative 2 before, here you have to recompensate for that negative 2.
Just write plus.
Okay? Right. Eventually, we're going to change it all to plus. So this is y equals negative 2, x minus 3 over 4 squared. And then here I have minus 12 plus 9 over 8. So finally, y equals negative 2, x minus 3 over 4 squared minus 87 over 8. Okay? Yep.
Why can't you just divide the 12 by 2?
You can't because we're just factoring that. If you do that, you would have to like divide this by 2 as well. You have to divide the whole equation, right? But we're not doing that, right? But imagine if you did, then you would have to, then this would be y over 2. Then you would have to multiply 2 back, and then it all comes back. So it all works out. Okay, let's do another one, and then it'll set in. Okay, so let's do this, and then we're going to graph. So y equals, okay, x squared plus 4x plus a number plus 6 minus a number. What number goes there? 4. So I get y equals x plus 2 squared plus 2. Okay, so negative 2, positive 2, that's the vertex, right? Negative 2, 2. And then I go over 1, up 1, over 2, up 4. 1, 2, 3, 4. Okay? Fabulous. Okay, let's do the next one. So here we have to divide by 2. So y equals, take out negative 2, I get x squared plus 6x plus a number minus 17 minus negative 2 times a number. Okay? Don't forget that negative 2. That's probably the most common mistake here. So what number is going to go here? 9 and 9, right? So here I get y equals negative 2, x plus 3 squared. And what do I have here? Minus 17 plus 18 plus 1. Okay, questions? Okay. Are you guys sure you don't have questions, or you just don't know what to ask?
Yeah.
Okay, let's do.
I'm confused, but I don't have a question.
Yeah, because it's so new, right? We just need some practice. So let's graph. If I go over 1, where do I go vertically?
Up to.
Down 2. And then if I go over 2, where do I go?
8.
Down 8.
Wait, where are you getting this over 2 over 1 stuff?
Last 2 chapters ago. Hang on.
And is that from the 1 at the end?
From the negative 2.
Right. So however much you go over horizontally, you have to go the square of that vertically. But if there is a stretch, then you also multiply by that number. We did it in chapter 2, so we're going to go back in chapter 2 and maybe review. Okay? All right, let's do this next one. Oh, we don't have a constant here, but that's okay. So y equals negative 2, x squared minus 5 over 2x plus a number. Does that make sense? And then outside, I have minus what?
Negative 2 times.
Minus negative 2 times a number. So can I just do plus 2 times a number? Yes, I can.
Y plus 2.
Okay, so it was like this. So I'm going to do minus negative 2 times a number, but I could just do plus 2 times a number. Okay, so what number goes there? 5 over 4 squared, 25 over 16. 25 over 16. So this is going to be y equals negative 2 times x minus 5 over 4 squared plus 25 over 8.
Why is it 25 over 8? Because you cancel out the 16.
Okay, so now we're gonna graph this. Okay? Are we ready to graph? Okay, so suppose you don't have your calculator, right? But that's okay. 5 over 4, I know, is 1.25, right? Okay. 25 over 8, how much is that? A little more, how much? 8 goes into 25 how many times? 3?
A little left over.
3 and 1.25. 1 over 8 is 1.25 actually, yeah. But you're right. 3.125. Okay, so now it's 3 and a little bit over. When I'm graphing here, who cares if it's 3.125 or if it's 3.237? I mean, you can't even tell the difference, right? So it's okay. We can estimate a little bit, right? So 1.25 and 3.125 here. Now, for this, because we're in the middle, going over and over, it doesn't really work as well. It's kind of more difficult. So I would also maybe like pick points, right? Or let's see, if I go over 1, I need to go down 2, 1, 2. So it'll be like somewhere over there, and that's good enough. Okay? Okay. Oh, this next one is a good one. Okay. So, y equals, take out the 1/2, x squared plus, now, before you yell out the answer, when you take out, when you factor out a number, you're dividing everything by that number, right? So when I factor out 1/2, it's like I'm doing 3 divided by 1/2, which is how much? 6. Right? So this will be 6x plus a number minus 2 minus half of a number.
Why did
Okay.
we do 2?
Huh? Because we took out 1/2.
Oh, it's not that you always do 2?
No, you
It's
do
just that I've just been always doing
whatever
2.
the number.
Oh, we've just always been doing
Yeah.
2.
Because then it gets too. Okay, so what's the number that goes there? 9. 9. So this is y equals 1/2 x plus 3 squared minus 2 minus 9 over 2 is minus 13 over 2, and that's that. Okay, so what's the vertex here? Negative 3,
3 and then like 6.
negative 6.5, right? 1, 2, 3 here. So if I go over 1, I actually go up 1/2. So that kind of works for this. Right? So I graph it like this.
And if you go over 2, do you go up 1?
Yeah. So do you guys see how powerful completing the square is? Right? Like how like far reaching it all is. Like you could do so much with this, right? Okay, any questions?
I have a lot of questions, but more like stuff that we didn't learn today, but they're not.
Okay, any questions about what we learned today? Okay. So again, there is nothing new in this page. All of this is stuff that you know. It's just like a little review / reminder. Okay? All right. So
Yay, we have a worksheet.
let's do it. Okay, that was a quick lesson. Yeah. Well, because we did a lot last time, right?